Hello students, in our previous session we have learned a new concept called as least common multiple. Let us solve few questions related to least common multiple in today's session. If you can recall, in highest common factor we had few questions like find the largest number which divides the given numbers by leaving some remainder, and we also had a question like find the measure of the largest or longest tape which can measure the dimension. In the questions related to least common multiple, you'll be having find the smallest number, something like that. Let's solve a question now. First question, find the smallest number which when divided by 25, 40 and 60 leaves remainder 7 in each case. In highest common factor, this was the largest number. Now the question is related to least common multiple. So we need to find out the LCM of these numbers 25, 40 and 60. To find, I will follow the prime factorization using division method. So when it is divided by the smallest prime 2, it becomes 20 times, this becomes 30 times. Further I will divide it by 2, it becomes 10 times and 15 times. Next I will divide this by 2 again. So 25 as it is, this becomes 5 times, this will be 15. Then I will divide by 3, 25 written as it is, 5 written as it is, 3 5s are 15, so 5 5s are 5 1s are 5 1s are once again 5 1s are 1s are 1s are 1 1 1. So we have to continue our division till we get 1 1 1. Then I'll find the LCM as the product of the numbers which are towards the left side. 2 multiplied to 2 multiplied to 2 multiplied to 3 multiplied to 5 multiplied to 5. In other words, this is 2 cube multiplied to 3 multiplied to 5 square. Here 2 cube is 8 multiplied to 3 multiplied to 25. And we get the product as 600. Therefore, the required number will be 600 plus 7, 607. So 607 is the least number. When divided by 25 will leave remainder 7. When divided by 40 also leaves remainder 7. And by dividing by 60, it leaves remainder 7. Let's see the next question. A boy saves rupees 4.65 daily. Find the least number of days in which ye will be able to save an exact number of rupees. Look at this, rupees 4.65 It is nothing but 465 paise. The number of paise, which is an exact number of rupees, will be the multiple of 100. So by considering 100 along with the given 465 paise, if I find the least common multiple, I'll be getting like LCM of 100 and 465 will be 100, 465. You have to keep dividing. If I follow a shortcut method, if I divide by the prime number 5, it is 20 times followed by 93 times. Here this 93 is a prime number, 5 is a prime number, so I can directly multiply this 20. This is a shortcut method. So if I multiply the product 20 into 5 and 93, this will become the LCM. So 9300 will be the LCM. So LCM is 9300. Therefore, the boy saves 9300 paise. If you divide the required number of days is obtained by dividing 9300 by the paise per day, we get it as 20 days. So minimum 20 days are required to make this as a complete rupee. Let's solve one more question. In this question, we will be finding the nearest number to 10,000, which is exactly divisible by 2, 3, 4, 5, 6 and 7. This type of question you must have come across in the entrance examination. The question is to determine the two numbers nearest to 10,000, which are exactly divisible by each of 2, 3, 4, 5, 6 and 7. To find the least number, I have to find the least common multiple. So 2, 3, 4, 5, 6 and 7, I should find the LCM. So I will divide by 2. Here there are 3 repeated 2 times, so I will divide by 3. Now if you observe, none of the numbers here in the last row are multiple of one another, so the LCM becomes the product of 2 multiplied to 3 multiplied to 2 multiplied to 5 multiplied to 7. We get it as 420. With this 420, I need to divide 10,000 to get the nearest number. 2 times is 840. Upon subtracting, we get 160. We'll take 10 from here. 3 times is 1260. We get the remainder as 340. Therefore, the numbers nearest to 10,000 divisible by 420 are 10,000 minus the remainder. The remainder is 340 we get it as 9660. To get the next number, I can add 420 to the number here. To this number, if 420 is added, we'll be getting 10080. So 10,080 and 9,660 will be the least number which are divisible by each one of 2, 3, 4, 5, 6 and 7. With this, I want to tell an important relation between Hcf and Lcm. What is that? This concept also you must have come across in your entrance examination. The product of Hcf and Lcm will be equal to the product of the numbers. Suppose if I have two different numbers, say 35 and 60. Let me find out the highest common factor. What is the highest common factor of 35 and 60? If I follow division method, 35 is a smaller number. It divides one time, so 35. Subtract 35 from 60, we'll be getting it as 25. So 25, you divide 35 now. One time is 25. It leaves the remainder as 10. 10 divides 25 two times. We get 20, and 5 divides 10 two times exactly. So the highest common factor is 5. Hcf is 5. Let me find out the LCM. What will be the LCM? So 35 and 60 I need to divide. So 2 divides 60 30 times. Then 2 divides 30 15 times. Then this number is not divisible by 3, so I can take 5 and divide both of them. I'll be getting 7 times and 3 times. Now these are the prime numbers, so the LCM will be 2 square multiplied to 3 multiplied to 5 multiplied to 7. 2 square is 4. This is 15 times 7, 60 times 7, 420. 420 is the LCM. Look at LCM multiplied to HCF. What will be the product? 5 into 420. This will be 2100. Now look at product of numbers. Product of numbers is 35 times of 60. It is again 2100. Therefore, we get the result HCF into LCM will be equal to product of numbers. This method is useful when one of them, that is either HCF or LCM or one of the number is not known. So for example, I'll give a question. The question is, the HCF and LCM of two numbers are 13 and 1989 respectively. If one of the number is 117, determine the other. If one of the number is known, how do we find the other? Suppose if I consider the other number, let the other number be x. We all know that the product Hcf into Lcm will be equal to the product of the numbers. So Hcf is given as 13, Lcm is given as 1989. X value we can find it out. X value will be 13 into 1989 divided by 117. This can be simplified. On simplification, we will get 221. So the other number is 221. Now, before ending this chapter, I would like to recall or revise a concept. So we shall have a revision of a concept called as test for divisibility. What is test for divisibility means? Suppose if I consider a number 2, which are the numbers which are divisible by 2? All even numbers are divisible by 2. Say for example 4, 6, 8, 10, 12, so on. They are all even numbers. They'll all be divisible by 2 because we define even numbers as multiple of 2. So all the numbers which are even, they are all divisible by 2. Which are the numbers which are divisible by 3? Suppose if you have 36, it is divisible by 3. The reason is 3 added to 6 we get 9. Sum of digits, if sum of digits is divisible by 3, then the number is divisible by 3. Let me take 4 as the number. Let me find out the test for divisibility by 4. If you consider an example, say 80372, can I say that this number is divisible by 4? For that, I want you to observe the number formed by the last 2 digits. This is 72. This 72, is it divisible by 4? 72, is it divisible by 4? 4 ones are 4 and 3 remains 32, 8s are 32, so 18 times. So it is divisible. So whenever the number found by its digits in tens and units place is divisible by 4, the number is divisible by 4. If the number formed by tens and units place is divisible by 4, then the number is divisible by 4. Suppose if I have 1, 3, 4, 5, 6, 1, 2, this particular number is divisible by 4. What I need to do is look at only the number found by last 2 digits. Tens place is 1, ones place or units place is 2, 12 is divisible by 4, so this number is divisible by 4. Let us see what is the test for divisibility by 5. We all have learned that whenever a number is ending with 0 or the number ending with 5, 0 or 5 in units place, then the number is divisible by 5. If you have a number 10, if you have a number 105, these are all divisible by 5. So we need to look at only the units place. If it is 0 or 5, the number is divisible by 5. What is the test for divisibility by 6? If a number is divisible by both 2 and 3, then number is divisible by 6. Say for example, if I consider 68370 a large number, first thing what we have to see is whether it is divisible by 2. Yes, it is divisible by 2. The reason is it's an even number. Is it divisible by 3? For that, let me add the digits. 6 added to 8 is 14, plus 3 is 17, plus 7 is 24, and 24 is clearly divisible by 3. Therefore, the given number is divisible by 3. Hence, both 2 and 3 divides the number. The number is divisible by 6. Okay, is there any test for divisibility by 7? There is no test for divisibility by 7. Is there any test for divisibility by 8? If the number is formed by hundreds place, tens place and units place is divisible by 8, then the number is divisible by 8. Let me see an example. Suppose if I have 207608, the number formed by hundreds place 6, tens place 0 and ones place or units place 8. If 608 is divisible by 8, then the number is divisible by 8. What is the test for divisibility by 9? It is similar to divisibility by 3. That is, sum of the digits we need to add. If it is divisible by 9, then the number is divisible by 9. Say for example, 7326 is a number. When we add this number, 7 plus 3 is 10, plus 2 is 12, the sum is 18. Is 18 divisible by 9? Yes, therefore 7326 is also divisible by 9. Is there any test for divisibility by 10? Yes, there is a test for divisibility by 10. One of the ways is, if a number is divisible by 2 and 5, then the number is divisible by 10. In other way, the ones place should be always 0. Then the number is divisible by 10. If a number ends with digit 0, the number is divisible by 10. So for example, 100, if I consider, clearly it is ending with digit 0, so it is divisible by 10. In other way, 2 divides 100 and 5 also divides 100, so the product also divides 100. One more very important test for divisibility you all must have learnt in your lower classes, divisibility by 11. This is little different, a special type. Suppose if I consider an example 3, 4, 6, 5, look at the odd places and the even places. Here the digits in the odd places are 3 and 6. The digit in the even places are 4 and 5. Their sum is 9 each. What is the difference? Difference of odd places sum and even places sum is 9 minus 9, which is 0. When difference in the sum of digits in even places and odd places is 0 or multiple of 11, then the number is divisible by 11. This is a test for divisibility by 11. With this, I can say that all the topics of this chapter are complete. Now we shall take up the questions from the exercise. Then we shall solve them. While solving, I'll be recalling all the concepts which we have learned. That's all for today's session. Thank you.